Hi everyone, my name is Christina Prella.
And my name is Janet Carr. Welcome to another episode of the Women in 3D Printing podcast. In spirit of the upcoming TIPE 3D Printing virtual conference taking place January 27 to 28th next year, 2021, we are going to be dedicating the first series to the TIPE. So you might be wondering, what is the TIPE? TIPE represents the tracks for the conference: technology, industry, people, and economics.
And as your hosts, we are so excited to share our conversations with these trailblazing women. The all-female speaker lineup we have prepared for this conference is made up of women that have carved their careers in additive manufacturing and have inspired all of us. We can't wait to introduce them to you so you can get to know them before the conference.
So we invite you to hit that subscribe button, follow us on LinkedIn, and get to know the stories of these awe-inspiring women before the event.
We'd also like to give a shout out to our platinum sponsors, HP, Trumpf, Matter Hackers, GE Additive, and Dassault for making all of this even possible.
I'm really excited to introduce you to our upcoming TIPE speaker, Amy Alexander, who is the Senior Biomedical Engineer at Mayo Clinic, part of the Department of Radiology in the Anatomical Modeling Unit. Thank you so much, Amy, for joining us today.
Thank you, Janet, for having me, and I'm excited to do this podcast with women in 3D printing.
Yeah, and we're excited to have you here. And the reason why we wanted to have you part of the podcast is to introduce folks to who you are, learn about your story so they get excited about what you have to say January 27, 28, 2021. I really want to dive into what launched your career in additive manufacturing and what got you started on this journey that is now inspiring many different hospital clinics today to follow in your footsteps.
My very first involvement in additive manufacturing was at my undergraduate alma mater, the Milwaukee School of Engineering. And there's a center called the Rapid Prototyping Center, or the RPC as the students know it. And you're allowed to place an order for a part that you design digitally and have it fabricated by the RPC. And in 2010, 2011, we were working on a cricoid monitoring system, which was our senior design project. And we had built some electronics that required a casing. And so we designed a very simple box casing with 3 holes in the top for different LEDs that were going to stick out for this cricoid monitoring system. And we had the box fabricated, and it was really my first exposure to the idea of if you can think it, you can build it. And that it kind of grew from there. So my first job after undergraduate was for a functional MRI company called Nordic Neurolab. And I was somewhat involved in the manufacturing process, at least during my training with Nordic. And then I served as a service and support engineer, but the functional MRI equipment was installed in the MRI suites. It was compatible with the high level of magnetic field that an MRI produces when in use. And, so I kind of had roots in radiology, and then the convergence of radiology and engineering and an opportunity to be a part of that convergence became available in late 2014 when a job opening at Mayo Clinic for an engineer in the Anatomic modeling lab became available. And so I applied for that job, and over a few different months of interviewing was selected as the first clinical engineer in the Department of Radiology for 3D printing.
And did you know you always want to go into the health sector, or you just tumbled into it like most people end up in their roles?
As a young kid, I grew up in Rochester, Minnesota. So Mayo Clinic has always been my primary care provider. And I was around folks who worked at Mayo Clinic. My mother's worked at Mayo Clinic for many years. In general, it was kind of the largest employer of the city, and one of the largest sectors that students and kids who grew up in Rochester knew that they could go into was the healthcare sector. Actually, I had always been fond of math and science, and did a lot of AP, chemistry, physics, and biology. But what pushed me toward the engineering field in healthcare was in 9th grade. I was in honors biology, and I remember my my teacher very well. She invited a biomedical engineer from Mayo Clinic to come and speak to our class about her work. This woman showed up and maybe spent, 15, 20 minutes describing what she did to our class of 14, 15-year-old kids. And she said, I'm a biomedical engineer. And the question was, what is that? We don't really know what that is. And she said, well, I make tools for surgeons to use in the operating room. And that was kind of the hook for me. I was like, wow, I didn't realize that I didn't have to become a direct patient care provider to have some sort of impact on patient care. From that point on, I was kind of hooked on it and started researching biomedical engineering programs over time. And after a lot of evaluation, ended up selecting the Milwaukee School of Engineering's Bachelor of Science in Biomedical Engineering.
Fascinating. And joining MSOE, did you purposely join it for the additive related activities there, which are pretty pronounced?
Okay, so I went to school in 2005. It wasn't even called 3D printing at the time. It was still called rapid prototyping. 3D printing name came about maybe 3-4 years ago, which I think was brilliant because it's enabled people to quickly understand what it is. Whereas rapid prototyping is a little bit different to get your head around if you're not, in a mechanical engineering space. So no, the answer is no. The reason I went to MSOE was not because of additive capabilities, although it did spark my interest in additive. The reason I chose MSOE was because they focus on, and this is not a marketed MSOE discussion in any way. I'm just kind of discussing my personal experience, but MSOE focused on hands-on learning. So not only were you learning the theory in your lectures, but the lab aspect of your classes was taking a lot of time, maybe 3-4 hour labs in a lot of cases. But what that meant was you would go and take what you were learning, the theory that you were learning in the lecture, and apply it to something and really build things as you were moving through the track of biomedical engineering. And what that consists of is a section of mechanical engineering courses and labs, electrical engineering courses and labs, and then biology, physiology. To have all those things come together was kind of a dream for me because I wanted to aspire to what that biomedical engineer said. I wanted to build tools for surgeons. And today I'm actually getting to do that.
You're one of the lucky ones that have found their way and navigated into a dream job. Congratulations on that, Amy.
Thank you very much.
But I'm sure the process wasn't so easy. And I'm sure you've met a lot of challenges while you were doing that. And I'm sure you even face a lot of challenges today because we're always talking about technology needing to catch up to what it needs to be so that we can really scale up this capability for 3D printing. What are some of the things that you're facing today that you can share so that we all know we're not alone and we're in this together?
Janet, you and I have known each other for a while now, and we've had separate conversations about, how it may look bright and shiny and perfected with a little bow on top at the end of your project. Your output or your product that you've developed may look nice and shiny and pretty. The reality is behind the veil, you're failing more often than you're succeeding. And that's kind of the point. You want to be able to be comfortable saying, oh, well, that didn't work, and move on to the next thing without, getting a bruised ego or feeling like you can't do something. Failing just means you've learned an avenue that isn't going to work, and you have to keep exploring all of the other avenues. I pulled this card off of my home office. I have this right on my monitor. And it's a quote from Thomas Edison that says, when you've exhausted all possibilities, remember this, you haven't. I think that really hits home for me as an engineer. Very infrequently are you successful on the first try. And if you are, you should probably question it. Perhaps you made some assumptions that you didn't account for, or you may have gotten lucky in a certain way, but you should test out all of the different parameters to make sure what you've done is repeatable and reproducible and functional for, the reason you're building that tool.
I think it's great to always get a reminder by Thomas Edison that, it's the 1,001st try that might actually work, maybe in the 10,000th time, hopefully sooner than later. What are some tips and tricks you can share related to how to systematically process all this information or position yourself to be able to solve problems better and quicker. Do you have some approach to that, especially in your field?
I think the most important thing is to not forget to take a step back and look at your larger picture and where your part of the puzzle resides in the greater scheme of things. For example, if I'm looking at a surgery where they need to make a very specifically designed cut in order to remove a tumor and the surrounding bad tissue, my part in that is to help the surgeon come in and see the radiological imaging, to see the three-dimensional objects, and be able to use the software tools to digitally place that cut. And then continuing on, the rest of my part is to make a tool, a cutting guide or a cutting device that will allow the surgeon to carry that through. But my job is not the whole surgery. My job is not to remove the tumor. My job is to create a tool to help the surgeon make the precise cut they need. And to know where you fit in that line of steps that are taken to rid this person of cancer, and to understand that each person on the team brings something different is really important. So taking that step back, looking at the bigger picture. In terms of systematically solving problems, I think organization is key. That's such a cliche, but you really do need to keep track of what you're doing and think about all the ways things can go wrong. A failure mode analysis is a good way to look at it. You don't want your device to fail, of course, but you have to, in order to do your due diligence as an engineer, you have to think of all of the possible ways it could fail and then figure out your mitigation plans. And that will guard you with that risk analysis. It will guard you against unexpected uses or failures of the device.
And I think that's really important, keeping note of what is causing failure so you can learn from how to mitigate that. That's for sure.
It's all about what you can learn from it. I mean, every single failure is actually another step toward a greater success.
But how do you make sure you don't burn through a budget for failure learning? Is that something that is
there's a compromise, there's a balance, right? Yeah. Between let's spend 10 years figuring out how this can fail versus at some point you have to just use it and see how it does. You're never on an island building something for the first time. If you've thought of it, chances are someone else has thought of it. So you lean on the experts in your field, you lean on those who have come before you. And like one of my greatest mentors, Dr. Jane Matsumoto, has always said, we all stand on the shoulders of the work of those who were here first. That could be centuries worth of people who have designed things. And although 3D printing has really become more mainstream in the last 30 years or so, traditional manufacturing techniques mirror what we're trying to do a lot of the time. I say, rely heavily on your resources so that you don't have to reinvent the wheel and burn through your risk analysis budget.
On that note, where do people find these giants that they can lean on? Is it research papers, going to conferences? Do you have top 3 people one should look at if they're in the biomedical engineering sector? Is it you? Can you share some more info on that?
That's a bit, it's so many things. So for those who are just getting started and say, hey, I like medical illustration and converting that into a 3D printed part, say something like that, then what I would do first is do your homework and look for the academic papers using, so in medicine, we use PubMed, which is a national, actually international resource where you can search things in quotations and say like medical illustration and then 3D printing, both in quotes. And you'll see some of the latest papers that were peer reviewed and published. And then just getting a feel for you don't have to read through the text of every single paper you come across, but what I do recommend is reading the conclusion section and reviewing all of the tables and figures so that you understand what the paper is saying. And then guess what? People love to talk about their work. So there's always a corresponding author on an academic paper, and they always include their email address. So if you don't feel like you're comfortable reaching out to them via email, maybe reach out to them via LinkedIn or another area called ResearchGate, which is another kind of like medical research social media. I think it's actually all research social media, but not just medical. But yeah, reach out when you have a name of a person who wrote a paper that you like, reach out and let them know, hey, I read your paper. This is really cool. People love to share what they've done, and chances are they're also willing to help get you acquainted with others in the field and set you on the right path toward the next internship or job interview.
Wow, that's fascinating. Thanks for that tip there. I'm sure a lot of people will now start looking at PubMed.
I still do that. When I find a paper that I like, I'm like, hey, I really liked your paper. Can we collaborate? Do you want to do a joint study? You know, that sort of thing. So people love to talk about what they've done, and for good cause. I mean, it's a lot of work to put something like that together. And like I said, we all stand on those shoulders.
Most definitely. And I think it's the same on the business development side that I've experienced. And even working on women in 3D printing, figuring out who do we want to bring to the TIPE conference? Obviously, Amy, and figuring out what has she done? Let's go ping her on LinkedIn. So thanks for that.
I try to keep it updated, but you know, it's hard. But seriously, you know, if people reach out to me on LinkedIn, it might take me a week or two to get back to you, but I usually do get back, and I'll try to connect you with the resources that are appropriate for what you're trying to work on.
That's really sweet of you. Now you're going to get a floodgate. That's going to be exciting. Speaking of, you know, getting in touch, most people are getting in touch because one, they want to better understand the process, maybe two, look at future developments. What are some exciting developments you're looking forward to in the biomedical field or 3D printing, or even just the point of care industry as a whole?
Over the last 5 years ago, we've seen an uptick in larger scale personalized titanium implants. You're seeing it from a group called Anatomic, based out of Australia, working with different hospitals around the world, and a few others, both nationally and internationally. But essentially what it's coming down to is patients have these large defects where a lot of bone has had to be removed for one reason or another. And designers are coming together with surgeons to design a replacement part. One of the more common ones that I've seen is a full sternum replacement with ribs and cartilage attachments. And it's really fascinating how they can change one person's life with a part that was specifically designed for that person. Although the regulatory and the quality and the risk elements are all very serious and are not to be taken lightly, I think we're also at this cusp where the technology is there, the material science is there, the designing, the engineering knowledge is there. So we need to come together to make sure that it is safe. We can be implanting people with 3D printed titanium implants. That said, those style of implants, as well as bioprinted implants, are, I think, the most exciting next chapters for 3D printing in medicine.
I'm sure there's a lot of things, you know, undergoing FDA clearance, and that takes a couple of years. Is this something that we're looking forward to next year, 5 years, or 15 years from now? Just curious, what is the timeline for personalized produced parts?
It's already happening in many places. It's not happening at my hospital quite yet because, again, we don't take those things lightly because we're a hospital system and not technically a medical device manufacturer. FDA is still figuring out those regulations, and we hope to guide them in coming up with some sort of a good way of regulating point of care manufacture of a bespoke device. It's a different ballgame than regulating a mass produced hip implant. But timeline, you know, it's happening now at a lot of places. You can request a patient specific implant, and we actually do it with a third party company right now. But in-house 3D printing of patient specific implants is probably 2 years out.
That's really exciting to hear, because that means there's going to be a lot more innovation happening at hospitals, that where the feedback loop is going to be a lot tighter to get parts to the patient.
I think that's the idea. And because the technology continues to advance, you can't ignore that application exists.
Unless you have a really robust, you know, 3D printing talent pool at hospitals, it might be quite challenging to stand up a program like this.
Absolutely.
What do you recommend other, point of care hospitals that are hoping to follow your footsteps or follow the footsteps of folks pursuing this area to do in order for them to get ramped up to offer similar services as well?
I certainly don't want to speak for other institutions. There's a hospital in New York, the New York Hospital for Special Surgery has partnered with Lima. And so what that looks like from the outside is basically Lima has a 3D printing lab within the hospital. And they're running the equipment and they're validating the processes, they're verifying the parts. And the hospital special surgery is working with them to design and then utilize the part. Conversely, at Walter Reed in Bethesda, they have a metal printer in-house and they have been printing implants for their own patients for years. That type of integrated system inside the hospital is likely uncommon, right? It's difficult to be able to have not only to find the right people, but to budget for the right people to run printers inside the hospital setting. What we're seeing a lot of is hospitals that are tied with universities, and the engineering departments of their universities are kind of stepping in and saying, hey, do you want to partner here where we can make you some anatomical models off of the segmentation that you do? Or, we have the printers, we have the personnel, or we have the students who know how to run them. How do we collaborate? So outsourcing is always going to be an option. And some people even discuss outsourcing just the printer maintenance itself. I think there are so many different hybrid models that people can come up with, and it totally depends on the surgical needs. If they need one model a month, I don't see how it would make sense to hire a full engineering team to run a number of printers. But if they're needing maybe 3,000 models a year, like our lab, we do have 9 full-time staff running. Right now it's 16 production printers specifically only for clinical use. And that doesn't include all of the R&D happening in the Division of Engineering or at other sites across Mayo. So it really is a recipe for what do you need and then how do we meet those needs.
And that's very inspiring, especially for folks figuring out what is the right approach. So thanks for sharing that.
Yeah, there's not a one-size-fits-all answer, but I thought about this a lot. I think there are folks out there who consult on this sort of thing, and you can ask, hey, I know you've been in this business for a while. Here's what my customer, the surgeon in our case, wants. What equipment do I need? What personnel do I need? What footprint do I need to make that happen? And that kind of knowledge is just learned over time, I think.
And not to talk too much into how to build your own infrastructure. I think recently Dr. Morris at Mayo Clinic was talking about how do you set up your infrastructure so you could get insurance covering the parts, which would help increase adoption. Since I've also recently spoke with someone, a device manufacturer, and they were saying that anatomical model and tooling jigs and fixture penetration in hospitals isn't actually as high as it could be.
No, not at all. I mean, the last numbers that came out were something like 260 hospitals in the US had in-house 3D printing capabilities, which is a great number considering it started at none. Just a note on the reimbursement aspect, there are category 3 codes out there that are in use by a number of institutions, my own including, with a very high reimbursement rate. And so it's scary to think that this is still only in the temporary reimbursement category, because that's what category 3 codes are. But the more we utilize the category 3 codes and the more we continue to publish and work together on the multi-center data studies so that we can say, this is, quantitatively how this has impacted patient care. Those types of results are what's going to push for a permanent category 1 CPT code.
Fascinating. So basically, folks out there, keep documenting, keep publishing your results.
Yeah, and utilize the RSNAACR Registry. If you're not familiar with that, it is on the National Radiology Data Registry site, and any institution who is doing clinical 3D printing should register for that, and then you can enter each of your cases that you do, and that metadata will be analyzed and put forth to the AMA to push for the Category 1 reimbursement code. So that work has been done by Dr. Jane Matsumoto, Dr. Frank Rubicki, Dr. Bill Wiedock. I mean, there are so many I could name, Dr. Jonathan Morris, Dr. Peter Koris, Dr. Adnan Sheikh. There are so many people that have contributed to that from an RSNA perspective and an ACR. Dr. Ken Wang, a huge proponent for the registry, a lot of work. Dr. Justin Ryan, now I'm just getting silly, but there's so many people. I'm sure I left a billion people out, but so many people have worked so hard to get us to this point. And so I think those of us who are doing clinical 3D printing need to utilize this resource very seriously and put forth that data so that we can continue to push.
Well, thank you for name dropping so many people now. We can all do some more studying and research and take advantage, because, you know, at the end of the day, like, events like this is to help promote and spread awareness, right? So more people get involved. So thanks for sharing that.
Again, you take those names and put them into PubMed and you'll see a lot of the early groundwork for 3D printing in medicine. Andy Christensen, I got to put that name out there too. I mean, Laura Lynn McDaniel, everyone has been extremely, extremely hardworking in these efforts. And yeah, like I said, we stand on those shoulders.
Yeah. And speaking of standing on those shoulders, what about folks that are excited to get in and they want to dedicate their careers or the next portion of their lives in this field? What do you recommend?
There's just so much. I recommend joining as a student the RSNA. The RSNA is open to anyone who's working in the field or aspiring to work in the field. I recommend following folks on LinkedIn. I recommend following companies that are doing 3D printing in medicine on LinkedIn. Me even doing Google alerts for 3D printing in medicine. There is a great Springer Nature journal called 3D Printing in Medicine. There's also one called the Journal of Medical 3D Printing that's more based in the UK. Follow those journals, read those articles. And again, you don't have to read every single word, but read the conclusions and check out the any visual aid that they give. And then just, you know, find someone whose work you are familiar with, whose work you admire, whose work you would like to be doing, and reach out to them.
Basically immerse yourself in knowledge and do it some more with the people that are actually building it so that you yourself could make better decisions.
Absolutely. I mean, don't be afraid. Don't be shy. We need young people and new people in the field to continue to push this forward. And we welcome you.
And is it so hard to jump from another industry into what you're working on today? Like if someone was in automotive or aerospace or consumer products, like,
sure.
What do you think about that?
We actually see a lot of people go from aerospace into medical. And I think the level of precision that's required for aerospace is at least on par with, if not more stringent than what is required by a lot of medical regulation. Not only the regulation portion, but I think just the human impact. People are drawn to that. I think even if you're just a student and you have very basic understanding of engineering principles, you know, I wouldn't discourage you from continuing learning. Come in from any avenue. We have people who were graphic designers now working in medical 3D printing, medical illustration. You have engineers, of course, you have surgeons, you have radiologists, radiology technologists, people in finance, people in marketing. It's not closed to just a single type of person like myself. I'm a biomedical engineer, but I work with mechanical engineers. I work with healthcare technology management and operations management. I mean, if you're interested in it, you're passionate about it, there's bound to be a place for you.
One last question I have, if you don't mind me asking, is sure. You don't have to necessarily be an engineer to jump into this. There's so many other auxiliary functions that have to be considered to enable this technology, such as spreading awareness, maybe on the sales and marketing side, education. What is needed in this sector to really get every physician or other types of internal customers to consider using 3D printing as part of their potential tool for surgeries or tool for preparing themselves to become more precise with their activities?
I just had this conversation with April Kravaniak, who is an engineer in the UPMC's 3D printing in medicine lab. And, you know, we were talking about adoption, like you say. And you can't, I don't think it's fair, and I don't think it's right to assume that an engineer or an outsider knows what a surgeon needs. In order to understand their needs truly, it has to come from them. They have to say, you know, I have to make this precise cut, but I often find that I'm a couple millimeters off or a few degrees off, and I would like a tool that would help me to make that more precise. So what they need to know is that we have the equipment and the technology to get them that tool. So in order to make that happen, it's all about the marketing, and it's all about case studies and showing people what can be done, because if they don't know it can be done, how can they order it? I really dislike the idea of an engineer coming up with a tool on their own and then kind of shoving it at the surgeon and saying, here, I made you this thing, now go use it. I don't think that's the right approach. I think it has to be a collaboration between the surgeon and the other medical specialties, with the engineer just saying, hey, if this is your problem, I think I could design a tool to solve that. So it's all about increasing awareness. And Mayo Clinic had a fantastic art exhibit, actually, with a bunch of our models in 2019 or 2017 already. Oh my gosh. And it was just gorgeous. You know, the arts department came in and made everything look so beautiful by taking radiological data and then high resolution photographs of the models we make and telling the story of the patient. I think that's what gets people hooked. And then a lot of times you'll have surgeons who are also tech buffs, and they get interested in how they can push their own practice forward.
Thank you so much, Amy, for sharing that. It's how do you package the story? How do you not turn off your internal customer by saying, hey, I think this works, and just use it? Really taking time to listen and be empathetic and caring towards what they're trying to solve, and creating that partnership and trusting relationship to deliver on that promise.
I think so, yeah.
Well, thank you so much for giving us a snippet into your world, Amy. And I'm sure everyone will be really excited to learn more about what you have to say at the TIPE conference.
Thanks so much, Janet. Happy to be involved, and thanks to Women in 3D Printing.
Thanks again for joining us at the Women in 3D Printing podcast TIPE Series. If you like the content, please hit that subscribe button, follow us on LinkedIn or other social media platforms.
We'd also like to give a shout out to our platinum sponsors, HP, Trump, GE Additive, Matter Hackers, and Dassault for making all of this even possible.
And visit us at type3dprinting.com to save your seat. And feel free to drop us a line if you have any questions or feedback.